Here's an example of using elimination back substitution to solve a 3x3 system. That's 3 equations and 3 unknowns. Linear system, of course. I should say linear. We don't try to do this. It's much more sophisticated if it's not linear. So here's the original system we have. And what I want to do is I want to display this in the way I want to see it in your homework, which is one part of the page, usually the left-hand side of the page, is just a sequence of versions of this system, equivalent versions of the system, until we get into triangular form. Now with 3x3, that's going to be just 3 different versions. It's not a lot of writing. And then on the right-hand side of your page, or somewhere, preferably the right-hand side, we'll see all the scratch work. And it's up to you how much scratch work to do. I'll show you a version which is a lot of scratch work, but you can do more in your head if you really want. Okay, so we start out with this system of equations, this 3x3 system. And the first thing we can do, so the idea is we're using this as a tool. It's called a leading entry because it's the first non-zero entry in its equation, or a pivot. And we're using that, pivot's the term I'll probably use. We're using that as a tool to kill the coefficients of x in below them. And here that's not too bad because it's easy to see what multiple to use. We'll do examples where it's a little bit trickier with fractions and stuff, but here I picked one where it's not too bad. So what we're going to do is we're going to take 4 times that equation 1 and add it to equation 2, and that's going to be the new equation 2. And so let's go ahead and just write that out. And just going to multiply that by 4 real carefully. And then I'm just going to put in also equation 2. Now you can multiply both of them if you want. The cleanest method, if you can do it, is to only use a multiplier on the tool, the row that's coming in to be the thing that changes the row, and always have a +1 here, but it's not super essential. Sometimes it's more essential, but for us it's not going to be super essential. Okay, and now I'm just going to add in columns. I'm going to get 0x plus 3y plus 2z equals 6. Okay, and now that's going to be the new equation 2. Okay, so I'm not going to put that in. Actually, yeah, let me start writing it in. The thing that often weirds people out is we're just going to rewrite that first equation because we want to keep that information. We're using that as a tool, but we also need to keep it for back substitution. And now we can copy in the new version of equation 2 if I do Control V instead of just V. And then I'm going to leave a space for the new version of equation 3. Okay, so now what about that? What about, so we're going to take 3 times equation 1. We could do various things. We could multiply it by -3 and add it to 3, or we could take 3 times equation 1 and subtract. Let's do -3 and then add. It's probably safer to deal with the minus signs just in the multiplication stage and then just add. Okay, so now that's going to be, we'll bring in this equation here, and I'm going to go ahead and multiply it. So that's -6x minus 3y plus 9z equals -6. And then bring in equation 3. Here I don't have to multiply it by anything. And I'm going to add them together. So 0x plus 6y plus 6z equals 9. Okay, and I'll copy that over. Okay, now I don't really have to have the 0x's in there, but it doesn't hurt me to have it either. Okay, so now I'm one significant stage simpler. I've gotten zeros. These two equations do not involve x. And so one reason why this is going to work is that this is basically its own little 2x2 system. I can pretend for the next step that that's the only thing in the universe, and that I'm just going to go ahead and use elimination on that and use this coefficient to eliminate this guy. And that's exactly what we'll do. Okay, so now those are now equations 1, 2, and 3. And what am I going to do? I'm going to take, let's say, -2 times equation 2 plus equation 3, and that's going to be the new version of 3. And let's go ahead and do that in the scratch. So let's see. Now the equation 1 is done as far as elimination is concerned. I'm not going to touch that. And even this guy, I'm not going to actually change it in place. I'm just going to use it. So I'm going to change it over in the scratch work, but not in where it really lives. Okay, so that's going to be -6y minus 4z equals -12. And I'm just going to copy in the old 3, and I'm going to add them together. So that's going to be 0x plus 0y plus 2z equals minus 3. Okay. Let's see if I got it right here. Just want to check the signs here. Okay. Okay, so we got 3y 2z 6. Okay. Sorry, just even if you've done it before, sometimes the signs go wrong. I just want to double check because it seemed a little weird. And then here's the scratch work for this one. Okay, looks good. So now I'll just put that in as my new system. Just copy these two in. Oh, actually, I don't think I can copy all those together. Copy that in. That guy didn't need to get changed. It was already good to go. And now the new one, bring this over from the scratch work. Okay. So here's our triangular system. That's the part where I really want it to be really clear, where there should be part of your paper where it's just here's the original system, here's the new version of the system, and here's the new version of the system, and that's in triangular form. Now we can do it a little more ad hoc. We can just start solving. Z is just going to be equal to minus 3/2. And then let me just do a new display. Then 3y, then I'm going to put in 2z, but 2z is just minus 3. That's equal to 6. And so 3y equals 9, and so y equals 3. Groovy. And then way back to the original equation, this is where we actually use that one more time. 2x plus 3, just going back to here, plugging in y equals 3, and then minus 3 times minus 3/2 equals 2. So 2x plus, we're going to have to go ahead and, actually let's just multiply everything by 2 right now. 4x plus 6 plus 9 equals 4. Or 4x equals 4 minus 15 is minus 11, and x is minus 11/4. And so let's just express it as a triple to put it all together. Minus 11/4, 3 minus 3/2. And we're done.